Greetings, I'm Orna Mehta for Mehtamatics for geometry proofs, and today we have some that will convey how to critically think and formulate ways to prove claims in mathematics. So right here we have that given that segment BD is the perpendicular bisector of segment AC. Prove that point D is equidistant from points A and C. Well, in truth, what we're doing here is we are proving something called the perpendicular bisector theorem, which states that for any point that lies on the perpendicular bisector of a line segment, that point is equidistant from the endpoints of that line segment. Also, essentially, this problem is asking us to prove that segments AD, as illustrated here, is congruent to segment CD. Because if they're congruent, then they have the same length, and therefore D would be equidistant from points A and C. So let's look at this first statement. BD is the perpendicular bisector of AC. Well, this fact is given in the proofs situation here. So therefore, our reasoning would be given. It would just be given. But now we have a missing statement. Well, you can think about this, that in this logical process in which you're trying to deduce why your claim must be true, every statement is a further logical deduction towards that conclusion. So, each statement is logically based on the statements that come before it. So, for example, let's take a look at statement 4. The measure of angle ABD is equal to 90 degrees and the measure of angle CBD is equal to 90 degrees. Well, this would be resultant of the intersection of perpendicular lines, because perpendicular lines intersect at 90-degree angles. So, that would be most likely what statement 2 is. BD would be perpendicular to line AC, but BD is already stated as the perpendicular bisector. And if we look in a helpful terminology, a perpendicular bisector is defined to be perpendicular. So, statement 2 would be that BD is perpendicular to AC. Reason, definition of a perpendicular bisector. And now we have that AB is equal to BC as our third statement. Well, this would be resultant of a bisector, because a bisector splits a segment or an angle into two equal halves. That's what a bisector does. That's the definition of a bisector. So therefore, the reason for statement 3 would be definition of a bisector. Now we have that the measure of angle ABD is 90 degrees, measure of angle CBD is 90 degrees. As we discussed earlier, this would be because of the intersection of perpendicular lines. So, the reason here would be the definition of perpendicular lines. And now we have statement number 5, which is that the measure of angle ABD is equal to the measure of angle CBD. And this would be because ABD and CBD, they are equal to the same thing. The reason for this statement here is the transitive property. As we can see in our helpful terminology, the transitive property states that if A is equal to B and B is equal to C, A is equal to C. That translates into if two things are equal to the same value, same number, then those two things are equal. So we have transitive property here. Now for statement number 6, we have no statement, but we have a reason. Now, take note that statements are logically derived from the statements that come before it. They're based off of the statements that come before it. So what we can do is we can reverse engineer in senses from our conclusion that point D would be equidistant from points A and C. We can reverse engineer from that conclusion to find out what these missing statements are. Well, we can see that ABD forms a triangle and CBD also forms a triangle. And these triangles appear to be congruent. Well, if they were congruent, then segments AD and CD would be congruent to each other. They would have the same length because CP, CTC, corresponding parts of congruent triangles, are congruent. And these are corresponding parts. They are the hypotenuses of both triangles. So, we're going to need to prove that these two triangles are congruent. Now, if we look at it, we'll see that we know that AB is equal to BC and angle ABD is equal to angle CBD. Well, we can form an SAS congruency and conclude that both of these triangles are congruent. So, we just need to show that BD is equal to BD. Well, that's called the reflexive property. Angle A is congruent to angle A, and segment AB equals segment AB. So, our sixth statement would be that segment BD is congruent to segment BD. And then here, we would have that triangle ABD is equal to triangle CBD. That is the SAS congruency, side angled side congruency. Following that, as we have discussed, AD would equal CD because of corresponding parts of congruent triangles are congruent. And then finally, we can conclude that D is equidistant from A and from C because if both of these segments are the same length, then that does indeed mean, by definition, that D is equidistant from A and B. So, that's what the ninth statement down here would be. And the proof has been completed.